Hey guys, welcome back to the IT Classroom. My name is Donovan, and today we're going to talk about IP addresses and subnetting. This is one of the most crucial and fundamental parts of networking. You need to understand how this works in order to continue in your networking journey. And my hope today is to break what can seem like a complex and difficult conversation or concept down into something that's pretty straightforward. As always, if you have comments, if there's anything I go over or you feel I miss or wish I would have covered a little bit more, leave it in the comments. This whole channel is designed for you, the viewers, to learn whatever you really want to learn. So if you want me to dive in on something, just let me know. All right, so let's get started. We're going to talk about IP addresses and subnetting, as I mentioned, and we're going to start by stating something that machines only know zeros and ones. So when we're talking about IP addresses and you see something like 192.168.0.1, both the client and the server really have no idea what that is. So with that, how can we use IPs like 192.168.0.1 if all it knows are 0 and 1s? To answer that, we'll scroll down a little bit. And IP addresses are made up of 4 octets. An octet is made up of 8 numbers. So let's break down this IP 192.168.0.0 inside of octet so you can understand what this looks like. So in here, when I say there's 4, 192 is 1, 168 is another, 0 is another, and 0 is another. How do we actually get these numbers? We go back to our 0 and 1s. And we actually have a chart down here. And we can see that we have 4 octets and we have to figure out the numbers. The way that you read these are from left to right. So these 8 numbers make up 1 octet. So that's how you're adding to find these specific numbers. So if we want to do 192, for instance, you start from the left and go to the right. Let me grab my tablet real quick. Okay, so let's start with the 192. We're starting with the 192 up here. We are going to add, you just count. So 128, does that equal 192? No. So we'll add a 1 here. You have 128. 128 plus 64, does that equal 192? Yes. So I'm going to add a 1 here because that equals the number we're looking for. Once we have the number we're looking for, we're going to use zeros for the rest of it. This equals 192. That's our first octet. Our second one, we could do a similar thing where we will look for 168. We're going to add starting from the left to the right. So 128 does not equal 168, but we need that. We already know 128 plus 64 equals 192, so that can't be it. 128 plus 32 equals 160. And now we need 8 more to get 168. So it's not going to be 16. It's going to be our 8. And we hit 168. So these are going to be 0. And now we have 168. For our last 2, they're just zeros. So these are all just going to be 0 because we're not trying to add any numbers here. And we'll do the same for the bottom. Now we have 192.168.0.0, and that's how we create these numbers. A couple numbers to keep in mind. This is called a default. And the opposite, 255.255.255.255 is called the broadcast. You're sending it to everything. Okay, you're going to want to know these, especially for if you're doing an exam like the Network Plus. You don't want to know what the defaulted broadcasts are. Let's move on to a working example. So if we look down a little bit into some practical use, we want to talk about a concept of public IP and private IP. Public IP is going to be the IP that your ISP gives you. So when you sign up for internet, you're given a public IP address. In this example, we're going to say it's 20.15. some random numbers. Okay. it used to be that every device got its own public IP, but we found out a long time ago that we're going to run out of IP addresses if we keep doing that. So they introduced a thing called NAT, which is just address translation, and that's what your router does. And how that works is now every device behind your router on your, whether it's in your home or in a business or a hospital, they all use private IP addresses. They have a router with a public IP address, and that's what sends it out to the internet. So instead of assigning a whole bunch of IP addresses to every device, they could just assign like one, or a big business will use a few, but you're saving a ton of IP addresses by doing it this way. So how do these devices actually get their IPs? What can you choose from? That's an important concept to kind of know. So we'll go down here. We have different classes. We have Class A, which is, these are private IP address ranges. That's important to know. You have Class A, where you can start with 10.0.0.0. So you have Class B, which is 172.16 through 31. So you could use any number between 16 and 31 here, .0.0. And Class C, which is 192.168.0.0. Okay? Each of these have their pros and cons. The pro of a Class A is if you're like an ISP and you have hundreds of thousands of devices that you need to give IP addresses to, you're going to want to use a Class A. Class B is like you're a really big organization. You'll probably use Class B. And Class C is like you're a home or a small office. You'll see these concepts called host and network. And what that's referring to is the network is the part that's already established for you, the 10. These can't be changed. It's always got to be 10. And in Class B, it's going to be the 172 and then this number between 16 and 31. That's going to be your network. It's never going to be able to change. And Class C is going to be 192.168. That's your network. That's never going to be able to change. Your devices will always start with one of these, depending on the class that you choose. The other numbers are the host. And in Class A, you have 3 octets to choose from, which leads to millions of devices. Class B, you have thousands of devices with this huge range that they give you. In Class C, you can have like 254 devices, and this is per network. So we talked about the different classes above, and let's break down what they actually mean and what I talk about when I say networks and hosts. So for Class A, we have a range from 10.0.0.0 to 10.255.255.255. What does that mean? That means we have one network. It's kind of this single block here, this 10. It's going to be this 10, and then we have all these numbers that change. So we have one network, and inside this one network, we can do up to 16,777,214 hosts, usable hosts per network, but there's only one network. Then we have Class B, which is 172.16.0.0 to 172.31.0.0. That means we have 16 networks, because 16 to 31, that's going to be 16. And inside of each one of those networks, we could have 65,534 usable hosts per network. So that means, again, we can have 16 networks. So each network, all the way up to 16, could have that many devices on it. Class C, we have 192.168.0.0 all the way to 192.168.255.255. Networks is going to be 256. That starts at 0.0 and goes all the way up to 192.168.255.0, which leaves us 254 usable hosts per network. But what does this actually mean? Go back up to our house here. So now that we know our classes and we know how many usable IPs are available for each one, in this scenario, we only have a few devices, and for like a house, apartment, I'm not going to say apartment, for a house or a company, you're going to probably want a small company. You're going to want to use like a Class C, a 192. So remember, the first 2 octets cannot change here. Let me scroll this down just a little, make it easier for myself. So we're going to start with a 192.168.0.0. What can we change here? We could change the first octet. This is how you change the actual networks. Okay, so when I say if we scroll back down here and we say that there are, we say that there's 256 available networks. And what that means is this number can change up to 255. So we can go 0, 1, 2, 3, 4, all the way down to 255. So we'll just say, draw a little arrow here to symbolize it. 255. So you can't have anything in between that number, but then that number stays the same. That doesn't change. This now all becomes one section that stays the same. So let's just start at 0. Okay. So we already decided that we're going to do 192.168. That was given to us. We can't modify that. We can modify our network, and we're going to start at 0. Now we need to modify the host. This is the part where we can hand out IP addresses. So in theory, this goes to 255. But there's a concept called the network and broadcast IP. The network IP is going to be the first usable IP for the subnet. And I want you to make note of this. It's for the subnet. We'll talk about subnetting more. This is already kind of getting into it, but we're going to show how we can break networks up to even smaller pieces. A lot of times it's called super subnetting. You'll hear the term borrowing bits, which, to be honest, for me, always confused me when I was learning networking. All borrowing bits is just subnetting. That's just the math that you do to actually do it. But strip away any confusion around that. That is just subnetting. So the first usable IP for the subnet and the broadcast is the last IP of the subnet. And I'm actually going to change this. It's not the first usable. It's the first IP for the subnet. Okay. So that means that 2 IP addresses are always taken. Another thing to keep in mind that's super important when you're talking about subnetting and IP addresses start at 0. 0 is a number, so think of 0 as 1. That is where you're starting your count. So when you have these ranges, it looks like, well, I could have a range from 0 to 255 and 0 to 255. You actually could have a range from 1, a usable range for your devices are going to be from 1 to 254. And that's because you have these guys here that are taking the 0 and taking the 255. Okay? That means these devices in here, now we have our subnet. These devices in here can start getting assigned IP addresses. We could do 192.168.0.1. Okay? And this device can get the next one. These are all our usable IP addresses. 192.168.0.2. And if you had all these other devices, it would be 0.3 and 0.4 and so on and so forth. One thing I want to keep in mind is typically you would assign your router here. You would actually assign that the first available IP address. That's what typically most people would do. 192.168.0.1. And we would just like change this up here to be, the one that isn't used yet. So 0.5, because we already used 3 and 4 and 2. We used 1, and now we're going on to 5. Perfect. So this works well, but let's look at a bigger company. We will draw one over here. And now we have ourselves a hospital. Okay. And inside that hospital, we have, let's just do some other boxes here. Okay. We have our nurses, and they have 10 workstations. And then we have another department over here called billing. And they have 5 workstations. And then down here, we have IT, and they're just doing a lot of stuff. So they have 100 workstations. Yeah. I'm going to stick with the 192 for this example, just so this applies to our other ranges, but I want it to be consistent so nothing is getting lost here. So again, let's recap what we had before. Just a minute ago, we decided that we're going to use 192.168.0. We could have chosen any number up to 255 here. We chose 0.0. as our starting range. This was our IP range that we decided. That IP range gave us a total amount of 255 addresses, and we had a range, a usable range of 254, because we marked the first one of the subnet, which was 0, and the last one of the subnet, 255, as already being taken. So 254, that's why we started addressing at 0. So let's go back here. Let's say we have this hospital, and we don't want the nurses and IT and billing to all be on the same network. Okay? We could do a couple things. So let's go back. This is where subnetting is going to get interesting. We're going to first start with a really easy way to do this. We're going to have the same range, 192.168.0.0. That's our IP range. IP range. This is what our IT team gave us and said, do whatever you need to do, but use this range for your work. Okay, perfect. We could pretend each one of these are separate houses, and we could use our range and just give them new IP addresses. We don't want them to talk together. So this is important. When you're building out your subnets and your IP addresses, the devices that you want to talk to one another have to live in the same IP space or have a different way to talk. Like there's VLANs and things of those natures. But at a very high level, if you want things to just talk to each other and work right out the box, they need to be in the same IP range. So if you don't want them to talk, then you put them in a separate range. So what we could do is we could say, pretend we didn't use this range over in our house example. We could say, hey, this is our nurses 192.168. I'm going to give you 0.0. Okay. That gives us 254 available usable IPs. Cool. That covers this. We have 10 nurses. We have 254 available addresses. Awesome. Over here, we have 5. All right. No big deal. What I could do here is give you an IP range of 192.168.1.0. Now, this goes all the way up to 255 too. But notice, I changed the network part of this. So remember how I said once you add a number to that first octet, that first available one, that now kind of becomes part of the network? Just like on this side, the same thing happened. When I added a 0 here, I decided to start at 0. It's now part of this network. Well, the network is like the street address. And the last octet, or the octet that you're using for your host, think of it as like the house number. So this part is saying, if you want to get to the right street, if you want to get to Nurses Street, go to 192.168.0. If you want to get to Billing Street, go to 192.168.1. These two cannot talk to each other. Why? Because we changed the number here. Remember, these are our network. And these guys are our hosts. And that can be applied to the same thing over here. We have our network. And we have our hosts. Okay? So we're changing the network, which makes it all go together. This is now all of this is the network. And all of this is the network. And these are two separate networks. They can't talk to each other. If we go down here, 192.168.3.0. Again, this 3 is the network, different street than the 0. It's a different street than the 1. It's a different street altogether. We're now on IT Street, and that lives over here. So when you're looking at the maps and you say, hey, which way do I go? Like, I can go this way. I can go this way. You have these different streets. I could do a weird U-turn and go this way. Like, how do I go? You're looking at the network portion, the 192.168.0, the 192.168.3, the 192.168.1. Honestly, apparently counting is really difficult for me today. This should be a 2 because that would be the next usable IP address here. So I am going to delete this. Okay, so we have 2 and we have 1 and we have 0 and we still have all the way up to 255, but only 254 usable IPs. So now we have 100 workstations. We have 254 addresses. That covers it. We have 10 workstations. We have 254 addresses. That covers it. We have 5 stations and we have 254. That covers it. Awesome. We're good. These guys can't talk to each other. That's great. But there's a better way that we can actually do this. So let's go ahead and delete this. Okay, so oftentimes you're given a specific range with the subnet already defined. So in this example, we have 192.168.0.0/24. That's our IP range that we can work with. So in the last example, I showed you that we could move the third octet number up to 1, 2, 3, 4 to easily make separate networks here. But sometimes you're restricted to one IP range and that subnet, and you have to still separate these to be on separate networks. So I'm going to show you how to do that. To get started, you want to look at your largest number first. So the department with the largest amount of workstations, in this scenario, it's going to be our IT department. And they have 100. You always want to accommodate for some growth. So I always accommodate for like 20% growth of whatever I'm looking at. So in this, like 120-ish would be good. So let's look at how you actually do that. So going back to our binary, now we know that the first 3 octets are already used because we already were given a /24. So the 192 is always used in class C. The 168 is always used in class C. In this scenario, the .0 is going to be part of our network. So now we crossed all those out as well. So these 3 are now part of the network, and we can symbolize that down here with the 1s, and the 0s are part of our host. So we have 255 available, but we still need these to be separate networks. So the way we do that is we subnet it. So we look at our top up here. I'll move it over so it lines up with our last octet, so it's easy to kind of line this up. So this 0 would represent 128, and we're looking for a number that makes sense to line up with the number down here. So we need 100 workstations. 128 would accommodate that, and it has some extra room for growth. So we're actually going to use that one. And the way that we use this is we draw a line here. And now, instead of this being 8, 16, 24, this actually becomes a 1 because we drew our line to make it a /25. So you're just counting the octets, 8, 16, 24, and then one more is 25. So we'll write that down here so everything is going step by step. The starting number doesn't change because we're starting at 0. This is the beginning of our IP address space. So we're going to start at 0, and it's going to be a /25. In order to find out how many available addresses this gives us, we will count the amount of bits to the right of our line. So put our line here. 1, 2, 3, 4, 5, 6, 7. And the equation that you're going to use in this scenario is just going to be 2 to the power of the number of bits. So in this case, 7, which will equal 128. And now we know based off of that what our range is going to be. So if we go back down here, now we can write that out so it's easy for us. So our total range will be 192.168.0.0 to 192.168.0.127. Remember, 0 is considered a number, so it's 128 total, including 0. So that would be 0 to 127. The first and last numbers are used by our broadcast and our network address. So let me just write that in here. So our network address will be 192.168.0.0. Our broadcast address will be 192.168.0.127. Remember that the network is always the first usable IP of the subnet, and the broadcast is the last IP of the subnet. And that gives us a usable range of 192.168.0.1 to 192.168.0.126. So now we move on to the next largest, which is 10. But we also want to look at the whole picture and plan ahead when you're doing these. So we have 10 and we have 5. Remember, we want to allow for a bit of growth for both of these. So let's look at what that really means in practical terms here. We have 10 and 5. We have to keep building in mind, but we're really looking for 10. So if we go over to our chart here, we already used 128. We can actually cross that one out right now. And now we're looking for 10. So 64 would accommodate 10, but that's pretty big. So we're not going to use that. 32 can accommodate 10, and that leaves a good amount of room for growth. 16 also accommodates 10 and leaves a pretty good amount of room for growth. However, if we were to use the 16 here, that would only leave us an 8 to use for our billing workstations, an 8 or 64, because we haven't used 64 yet. And I'll explain that in a little bit, but that would realistically only leave us at 8 because you're trying to use as close to this number as possible, the amount needed, with leaving some room for extra. So we're actually going to use 32 because that would leave us 16 for our billing, and that's plenty left over. So let's go ahead and use 32 here, and we'll do the same thing. We'll draw a line. You always draw a line to the right of it, what that looks like in binary. I'm going to change this to a 1 because we actually used that 1 up here. This is still a 0. 64 is still available. That would be a /26. And now I'm changing the third one to a 1 because I want to use that. And that's going to be a /27. I'll add a line here. Remember, always add the line to the right. So now we can start writing what this would look like. So we'll go in here and we'll do the same thing. Our starting IP is going to pick off where the last subnet left off. So we ended on a 127, so we're going to start with a 128. So 192.168.0.128/27. Again, we got that 27 by just counting over 1, 2, 3 from 24, 25, 26, 27. And we can see it up here in our chart. 25, 26, 27. We did the same thing up here. So with that, we have a total range of 192.168.0.128 to, let's find what our ending is. So to find the total, we're going to do the same math, which is going to be 2 to the power of number of bits on the right. So 1, 2, 3, 4, 5. If we do 2 to the power of 5, that is going to equal 32. And we could just use a calculator to verify that. Perfect. So then what we could do is just add that down here. We're gonna do 128 plus 32 because 128 is a number, and that is going to leave us with 192.168.0.159. Because remember, we start at 28. That counts as a number to 159, meaning that we will have. Let me just wind this out a little bit so it keeps consistency. We have a network address of 192.168.0.128. We have a broadcast address of 192.168.0.127. 159. And that gives us a usable range of 192.168.0.129 to 192.168.0.158. And we'll widen this so we can see it all on the screen here. Perfect. So now we have our IT department set up with their own subnet. We have our nurses set up with their own subnet. So that leaves us with billing, which we already kind of accounted for up ahead. That's why we left the 16. So we added a line here. Let me go ahead and delete that. Got a little ahead of myself. So we'll do the same down here. I went ahead and added a 1 here and drew the line as well. So now we want to find what the subnet is. So we go 1, 2, 3, 4 spots. So that's going to be a slash 25, 26, 27, 28. So we'll go ahead and add that down here. Remember, we're going to start where our subnet left off. In this one, it left off at 59. So we're going to do 0.160. And we're going to go 2 to find what the end range is. You do the same math. 2 to the power of the bits on the right. 1, 2, 3, 4. 2 to the 4th power is going to be 16. Equals 16. That's the number that we wanted. So we will go ahead and we'll just add in all of our information here. We know we're starting here. We have a slash 28. Our first number is going to be 0.160. And our ending number is going to be 16 more. Remember, 160 counts as a number. So in this case, it's going to be 175 is going to be our total range. So let me just write in total range. Our network address will be the first IP available, which will be 192.168.0.160. Our broadcast IP is going to be the last usable, which will be 192.168.0.175. That gives us 14 usable IPs. This one here gives us 30 usable IPs. And down here, we have 126 usable IPs. I'm going to expand this a little bit so we can see the whole picture. Perfect. So now we broke down, we were given that specific IP range that was already locked in. This 0 was already locked into the network. So we had to get more creative with how we were going to separate these networks. By using subnetting, we were able to use that last octet that was available. And that's where the term borrow bits comes in. We started borrowing the bits. The bits are just the 0 and 1s. And we decided where we're going to place it and which ones we're going to borrow and which ones we're going to leave alone. So right now at the end, there's still a block of 64 that's available. There's a block of 8 that's available, a block of 4, a block of 2, and a block of 1. One thing I do want to call out about the 64 is this doesn't just pertain to 64. It pertains to anything you leave behind. But in this case, 64 is going to be the most applicable. When you start an IP range on a 64, it has to be a divisible number by 64. For instance, if I go down here and let me open up a new text box, I type in 64 plus 64 plus 64 plus 64. So let's just go one at a time. 64 plus 64 equals 128. 128 plus 64 equals 192. And 192 plus 64 is going to equal 256, which is the end of the IP. So if we wanted to use the 64 at some point, it would have to start at 192 because we already passed the 128, and 256 would be too high. That's the end of the network space. So meaning that let's say I had another department that came in and they were pretty big. So I'm going to move this out of the way for a minute because it'll override my stuff. Let me create another department here. And we will call this, this is the safety department. And let's just say they are really big as well. And they have 42 users. Okay. And we still need to use our range to accommodate for them. The only ones that we have left right now, like I mentioned before, let me go ahead and cross through. We use the 32, we use the 64. The only range that works for them would be the 64. But our ending range right now is at 175. The next number is 176. And that does not fall within the addition of 64s. So the only time you can use the 64 is if it were a 128 or a 192. So that means we would have to start our next IP address at 168.192.168.0.192. And we could draw our line again up here to see kind of what the subnetting and everything looks like. So when you go over, that would give us a /26. So I'll just add that here. We have a /26. We want to see how many addresses that gives us. To do that, we start here and we'll change this to a 1 now because we're also using the 64 mark here. So now we have, actually move that. I think I have one too many. So now we have 1. In this case, even though these are 1s, because we used them previously, they're still to the right of the subnet that we're doing. So we're still going to count these values. So we're going to go 1, 2, 3, 4, 5, 6. So we're going to change this to be 2 to the power of 6. Let's scribble that out. 2 to the power of 6, which should equal 64. So now we know that our range is going to be 192.168.0.192 to all the way up to the end of our IP range, which is going to be 192.168.0.255. Network IP will be 192.168.0.192. It's the first address. The broadcast IP will be 192.168.0.255, leaving us with a usable range of 192.168.0.193 to 192.168.0.254. And now we have accommodated. That also means that if we want to go back and use the 8, the 4, the 2, we need to use it between the ranges that we haven't already used. So if we were to use the 8, 4, or 2, we would pick up where we left off at 175 with the billing subnet, and we would do 176. Okay, now that we kind of understand Class C, let's talk about Class B and Class A. Subnetting works the same between these, but I want to show you some examples of what numbers we can manipulate, how they change, what stays the same. So let's go through it. Class B has a range of 172.16.0.0 through 172.31.255.255 with a default subnet as /16. Why is it a default subnet as /16? Because these first 2 octets are already used. So no matter if you're using 172.16 or all the way up to 172.31, these are going to be your network portion, meaning these last 2 octets are going to be your host. So that's where the /16 comes in. Remember, each octet has 8, so 8 plus 8 is 16. So we would draw a line right here. So what do some of these look like? You have your default, which is 172.116.0.0 /16. So that would be 172.16.255.255. These are the hosts that you could go up to. If you were to manipulate the third octet to be a 1, now this is all your network and this is your host. So you would have 255 in here. Same thing here. This would now all be your network. These would be your hosts, leaving 255. If you were to just leave 0 but change the third octet, what you did /24, this would all be the network. These would be your hosts, leaving 255. The same for these. If you were to go down here though and did /16, but you changed the second octet, which we can do up to 31, that would leave you with 255 here and 255 here for your host. So now you could still manipulate both of these or use both of these. And if you had a /19, or if you had a 172.19.0.0 and did a /16, again, this is your network and these are your hosts. And you could keep kind of switching all these numbers around and subnets around until you get to 172, 131, 255.255. That's going to be your last address in that class B. So if we look at some examples, subnet behaves the same as class C. It's just a matter of where you're going to make your subnets from. So like I said, we had a default of 172.16.0.0/16. So that meant that these first two octets, 8 plus 8, is already used. That's why we have a /16, leaving the last two available for use. But if we were to break it down and using our example from our class C, if we do a 172.16.0.0/25, that means we're going over 25 spaces in our octets. So 8, 16, 24, and then one more is 25. And our IP range actually looks the same as when it did on a class C, just the beginning numbers are different. So this would give us a range of 172.16.0.0 through 172.16.0.127, with the network being 172.16.0.0 and the broadcast being the last 172.16.0.127. And that gives us usable range of 172.16.0.1 through 172.16.0.126. Again, to find this, we do 2 to the power of the remaining bits. So 1, 2, 3, 4, 5, 6, 7. So if we do 2 to the power of 7, that equals 128. 128 starts at 0 and goes through 127 because 0 is a number, so that would be the 1, and 127 would be the last. And that's how we get these ranges. I'll write that out just so you can see it. 2 to the power of 7 equals 128. Okay? If we move down to our next example, this time we have 172.16.0.0/17. So we're changing up where we're going to break this down. What does that actually look like? This is 8. This is 16. That's the default, but we're going over 1 to 17 and we're adding our line. Our IP starts with 172.16.0.0 and it ends with 172.16.127.255. How do we get this 127.255? Same thing that we did before. We counted the numbers remaining 1, 2, 3, 4, 5, 6, 7. And we did 2 to the power of 7, which equals 128. That's how many are available in the octet that we're looking at, which is the third, which is why we changed the third here to be from 0 to 127. And then 255 is always what 8 zeros mean. So now we have a range of 0.0 to 127.255. That gives us a network of 172.16.0.0. That gives us a broadcast of 172.16.127.255. And this would be the usable IP range there. Let's go down and talk about Class A. Class A is our biggest network. It's one giant network and has millions of possible devices. So let's take a look at what that looks like. Start at 10.0.0 and go all the way up to 10.255.255.255. The 10 being the network. It has a default of a /8 because this is the only octet being used from the start. And by default, it's opening these up to do whatever we want with the remaining 3. But if you're going to have a network this large, you're probably going to want to break it down, because that means you're going to have a ton of other departments because you're a huge company like an ISP. So to break it down, we could just subnet really wherever we want in any of the remaining 3 octets. So let's just go ahead and take a look at what some default ones look like. If we had 10.0.0.0/8 or 10.0.1.0/8 or 10.0.2.0.8 or 10.1.0.0/8, any of these, they all, by default, when you're using the /8, they all fall in the same network because only the 10 is defined. And by default, these last 3 can be used for the host. So no matter what numbers we put in here, they're always going to be able to talk to each other. And that goes all the way up to 10.255.255.255, which is a broadcast for Class A. But we probably don't want all of these to be able to talk to each other. So let's look at some examples of breaking these down. So as far as subnetting goes, the behavior in Class A works the exact same as C and B. It's just you have more places where you can break networks out from. So an example of this is, let's go back to our original Class C and the one that we used in Class B, which is a /25. You're now taking this really big network that used to start with just 10 and leave all these open, and you're breaking it down to a much, much smaller network and say, no, I only want 255 hosts for this network. I don't want these millions of IPs. So to do that, we take our binary. 8 was what we had before, and we had a line here, but now we're going all the way over to 25 and drawing the line. So now this all becomes the network, and we only have these remaining IPs, which is going to be, again, 2 to the power of 7 is going to give us 128. So now we have a range of 10.0.0.0 through 10.0.0.127, just like we had in our C and B, with the network not changing because we started with 10.0.0.0. And we go to a broadcast of 10.0.0.1. This should be 127. I apologize. Let me change that. And usable is going to be 0.1 through 0.127. Example 2, we're just moving the / to wherever we want, whatever fits our needs based off of network and host requirements. So in this one, we're doing a /17. So let's see what that looks like. We have our original network, but now we are adding a 1 way over here at number 17. So now all of these become the network. Let's add a line here. So now our network is going to be 10.0.0.0 to 10.0.127.255. Again, we're just going to count the remaining numbers to the right. 1, 2, 3, 4, 5, 6, 7. The important thing to remember here is octets are all individual and unique to each other, so you're never going to count the bits in a different octet. You're only counting the ones inside of the octet that you're working with or concerned about. So in this one, it's going to be 2 to the 7th again, which we already know is going to be 128. That's how this becomes 128. So this is going to be 10. This is going to still be 0, but this is now to be 128. So that's going to be our usable ranges. So we have 10.0.0.0 through 10.0.127, because remember, 0 is a number, so 0 to 127 equals 128. And then, as always, all zeros is going to be 255. So this is our range of IPs that we can have now. Scrolling down, let's look at something besides a 2 to the 7th and see what that looks like. So in this example, we're going to do 10.0.0.0/12. The range still starts at 10.0.0.0, and the ending range is now going to be 10.15.255.255. How do we get that? This used to be our network, but now we went into second octet and we went 9, 10, 11, 12, and we drew a line here. So now all of this is our network. And if we use our MAC, 2 to the power of remaining bits, that's going to be 1, 2, 3, 4. So 2 to the power of 4 equals 16, with 0 being a number. That means that we could do 0 to 15. That would equal 16. So that's how we get 10.0.0.0 through 10.15.255.255. Remember, these last hosts don't change at all. They're separate because anytime you are going into another octet, you don't worry about the previous one. So all zeros equal 255. So now our number of usable IP addresses are 10.0.0.1 through 10.15.255.254. The last thing I want to talk about are some unique address spaces called Class D and Class E. Class D is a multicast IP range. It's 224.0.0.0 to 239.255.255.255. Class D addresses are used for multicasting. Instead of sending data from one computer to another computer, which is unicast, or from one computer to every computer, which is broadcast, multicasting allows a device to send a signal stream of data to specific groups of interested devices at the same time. How it works? Think of Class D like a radio station frequency, a server transmitting data on a specific multicasting address, for example, 224.0.0.5. Any router or network device that wants to hear the data tunes in to that address and receives it. Some common use for this is routing protocols, routers talking to other routers to share network maps, streaming live video or audio to multiple endpoints, and home smart device discovery. Class E is an experimental range that we as regular consumers can't use. That range is going to be 240.0.0.0 to 255.255.255.254. It's officially reserved by the Internet Engineering Task Force, IETF, for experimental and research purposes. How it works or doesn't. In practical everyday networking, these addresses are completely off limits. You cannot use them. If you try to assign an IP address like 254.10.10.1 to a Windows machine, a Mac, or standard router, the operating system will almost always reject it and throw an error. These are address spaces that we don't really work with all that much, but if you're taking an exam like the Network Plus or the CCNA, you're going to want to know these, especially for something like the CCNA where routing protocols use these Class Ds, so you're going to want to be familiar with those. And with that, that wraps up this lesson. I'm still new to filming and editing, and it's been super rewarding, but with that, I definitely have noticed some challenges. So if I covered anything too fast, or you feel I left something out, or you want me to explain something a little more in depth, just leave a comment and I could do a live on YouTube. I can make another video. Really, the whole purpose of this channel is to help you, the viewers, get practical real-world examples of how things are done so you can enter the job market as well. I hope this helped. Thanks again for watching, and I'll see you in the next video.